So in this video, I want to talk about the mechanism of action of glucocorticoids. Glucocorticoids stimulate the glucocorticoid receptor, a nuclear receptor, and as a result, they change the expression of several genes, either increase their expression or decrease their expression. Now, the most famous glucocorticoid is our endogenous cortisol. And cortisol is a glucocorticoid, hence one thing that it does, it raises glucose, as the name already implies. Another thing that is super important, in particular why we use these glucocorticoids as drugs, they decrease inflammation. So these are the most important effects of glucocorticoids. So now let's just look how these effects are mediated. Cortisol binds to the glucocorticoid receptor. The glucocorticoid receptor is actually not immediately found in the nucleus. It hangs around in the cytosol and is bound to heat shock proteins. So once cortisol binds to the glucocorticoid receptor, then the heat shock proteins actually diffuse away. Then we have this glucocorticoid receptor bound to cortisol. And this then moves into the nucleus and binds to DNA. And it's actually dimerizing, and the formation of this dimer helps that a coactivator can bind, so it generates kind of a binding cleft for a coactivator. And so we're going to have a very good transcription factor with the coactivator bound to it, which is generated by the glucocorticoid receptor, glucocorticoid dimerizing, and this will lead to an increased expression of several genes. And as we already said before, glucocorticoids raise glucose, so that means they will make more of different gluconeogenic enzymes. And that's exactly the mechanism how they increase the different gluconeogenic enzymes. So next we also want to discuss how it can be that other genes, particularly ones that are promoting inflammation like pro-inflammatory cytokines like TNF and IL-1, have decreased gene expression. The process starts similar. We have the glucocorticoid receptor bound to heat shock proteins, cortisol binds, and then the heat shock proteins are going to diffuse away. And now the situation is a little bit different. So we know that for several pro-inflammatory cytokines, a very important transcription factor is NF-kappa B. NF-kappa B, let's suppose, is activating several genes, and there's a co-activator that sits here. And so this transcription machinery is working. And we're going to produce several inflammatory cytokines. Now, when cortisol with the glucocorticoid receptor is moving to the nucleus, what is happening is that it's basically replacing the co-activator from the side of the transcription factor. And therefore, NF-kappa B cannot do its job as well. And as a consequence, we're going to get decreased inflammatory cytokines. So this is a mechanism that leads to decreased gene expression. And that's going to be what dampens the inflammatory response. So I just want to finish now with summarizing again the adverse effects of glucocorticoids, which are also sometimes referred as Cushing syndrome. So we said glucocorticoids raise glucose. Therefore, it's very predictable that you're going to get hyperglycemia if you're using glucocorticoids. Now, to make new glucose, we need also amino acids. So how do we get amino acids? We break down protein. We break down protein in muscle, so that leads to thin extremities. We break down proteins in skin, that leads to thin skin, and also purple striae, bruises and patches as we break down proteins from blood vessels and skin. Then second, glucocorticoids stimulate lipolysis. We're going to accumulate fatty acids, and they are going to go centrally, so we're going to see a moon phase and the buffalo hump, fat deposits, also particularly the belly fat, central fat deposition. Then we also learned that glucocorticoids are very detrimental to the bone. Therefore, we're going to have osteoporosis as a side effect. And because we dampen the inflammatory response, we dampen the immune system, we're also going to be more prone to infections. Now, some glucocorticoids have also mineralocorticoid effect. And mineralocorticoid effect is a sodium retention, potassium excretion. So always when we're going to hold on to sodium, water is going to follow. Therefore, fluid retention can also be a possible adverse effect if the glucocorticoid has also mineralocorticoid action. This concludes the video on an introduction to glucocorticoids.